Hi everyone, my name is Edwin Kwan, and I'm here to talk to you today about how your application is mostly written by strangers. Now, when I say your application, I'm referring to the applications that your company develops. As security professionals, we spend a lot of time educating our developers on how to write secure code. But the truth is, the bulk of your application is written by people who are not part of your organization. They're written by strangers. Now, this did not used to be the case. Applications used to be built from the ground up. Software development has evolved over the years, and today they're mostly assembled from a bunch of libraries. Now, this is similar to the construction industry, where building a house used to be done one brick at a time. It was time consuming, and the process was labor intensive. Today's houses can be assembled from prefabricated parts. The parts are built offsite and in bulk, and it reduces the construction time required for building the house. In software development, those prefabricated parts are open source libraries. And these open source libraries make up a large percentage of an application's code base. So here's what I'd like to share with you today. I'd like to talk about open source software. How much open source are we using and who develops them? I'll then share some of the open source breaches that have occurred in the last 2 years. And I'll finish off with what you should do to reduce your risk of an open source breach. So open source software. As I have already mentioned, it is now quite rare for organizations to write the majority of their software in-house. Instead, most organizations will leverage open source software to create the bulk of their software products. There was a survey that was released last year, which provided some stats on this. This was the 2019 State of Software Supply Chain Report, and it said that 85% of modern applications consisted of open source components. Now, I had to decide on my own, and I did my own analysis on some of the apps within my organization. So for one of the apps, we had 12 components that were written in-house. This was a Java Maven application. So these 12 components consisted of submodules and internal libraries. How many open source libraries do you think the application uses? 10? 20? 50? It uses this many open source libraries. So it had 12 in-house components and 268 open source components. So that means open source made up 98% of all the components that are in this particular app. What if we go by file size and say, for the in-house app, it was 504 kilobytes, and the open source libraries took up 86 megabytes. So that's about the same ratio, about 98%. And I found similar ratios with the other applications that I analyzed. And what this tells me is that our development team only writes a very small percentage of the code that make up our application. So who is responsible for writing the bulk of our application's code? Who are these open source developers? Well, open source developers could be individuals who devote their spare time working in the evenings or on weekends. And most highly successful open source software are not developed by a single person. So you could have multiple of these individuals working on the project. There could also be contributions by developers from companies who volunteer their company's time to contribute to open source. When I was researching for this particular slide, I actually discovered that Google and Microsoft are the top open source contributors in terms of repositories that they contributed to and the number of contributors. And open source software, surprisingly, also leverage other open source software. So you have a highly distributed team of individuals and companies working together using other open source software to develop their open source software. So you could say that open source software can be quite complex. Now, not all open source are created equal. As part of our organization's SDLC, our software development lifecycle, we have a number of processes in place to ensure that we are building our applications securely. We've got secure coding practices, where we obviously follow the OWASP top 10. We have integrated testing, where we check not only for common bugs and unexpected behavior, but also to check that there are no changes that have been made without the developer's knowledge. There's change control, so we're able to tell who made what changes and when those changes are made. And we also have two-factor or multi-factor authentication for our developer accounts and other important accounts associated with the project's design, deployment, and maintenance. So we're doing all this for the 2% of the code that we write in our applications. Now, do we know that the same is being done for the open source components that we use, which is the other 98% of our application's code? Now, not all open source are created equal. I'd like to now talk about some of the more recent open source breaches. The first breach that I'd like to share with is with a JavaScript NPM package called EventStream. Now, it's quite a popular package with just under 2 million downloads. This breach happened in November 2018, and the original author for the project created this project on August 2011 and has been looking after this for over 7 years. Due to lack of time and interest, the author for this EventStream library decided to hand over ownership to someone else. Now, unfortunately, this someone else turned out to be someone with malicious intent. The new owner included a malicious dependency called flatmap streams. And this malicious dependency was used to steal crypto wallet information, including private keys. The new owner even attempted to hide their activity by releasing subsequent versions that did not have the malicious dependency. Now, fortunately, the malicious code was discovered and reported. NPM had to intervene to remove the malicious versions, and they also took down the flatmap stream library. However, that wasn't the end of it. There were still multiple copies of the malicious version, as it was a dependency for many other libraries. And this was still being cached locally on developers' machines and in internal repository managers. NPM had to reach out to just under 4,000 project maintenance to ask them to update their dependency tree. Now, the cause of this breach was social engineering, which resulted in the ownership of the library being legitimately handed over to the attacker. Now, this next breach was on a RubyGems library, and it happened in mid-2019. The library is called Strong Password. Now, it was discovered by a developer who was upgrading some dependencies, and that person was doing some due diligence and going through all the library's change set line by line. Now, I'm really impressed by that because I don't think I do that myself all the time. So it's really good due diligence on this developer's part. While going through it, this developer discovered that Strong Password did not have a changelog file. And upon it inspecting the code changes, discovered the following lines of code. And This code allowed for remote code execution. The developer investigated further to find out who added those code and discovered that there were actually no code changes in GitHub. So GitHub was still showing version 0.06 as the latest version, with the last code change being 6 months ago. So it turned out that the maintainer's RubyGems account had been compromised. So the author had an old password, which was reused on multiple other websites, including websites that had previously reported data breaches. He wasn't doing much open source work and forgot about the RubyGems account, and hence did not update the password. And this account was created before RubyGems even had 2FA. So you could say that the cause of this breach is that there wasn't a strong password. This next breach is a lot more recent, and it happened in February this year. It did not involve compromising any accounts, and it works based on developers not realizing the typo in the library's name and picking the malicious library instead of the legitimate one. And the malicious gems originated from these two user accounts, Peter Gibbons and Jim Carrey. So the one I want to talk about is the one with the highest download count, which is Atlas Client. So here's a screenshot of the legitimate library next to the malicious one. Do you remember which is the malicious library? Is it the one on the top or the one at the bottom? It's the one at the bottom. And it turns out that not many people could, as at the time of the incident, when it was reported, the malicious gem had close to 30% of the total downloads. So what happened when your application uses the malicious library? Well, if it's running on a Windows system, it will rename the PNG file, aaa.png, to an executable. So it would be a.exe, and it would execute it. And this would create a new VB script file for persistence, and it would create a new auto-run registry key so that the malware will run every time the system is started or rebooted. And this script will start and do an infinite loop where it captures the user's clipboard data. It checks if it matches the format of a cryptocurrency wallet, and if it does, it replaces the address with that of the attackers. So there are actually real financial consequences to open source breaches, and they're not just to the end users of the affected applications, but they also affect the organizations who produces the application. Now, British Airways experienced this 2 years ago when it had a data breach of over 380,000 credit cards. It was subsequently fined $229 million for that breach. And all this happened because of a common JavaScript library, the Modernized library, which had 22 lines of malicious code included into it. So you could say that the fine worked out to cost around 100 million per line of malicious code. So there are real financial consequences to open source breaches. What should you do about it? Open source breaches are real, and open source is everywhere, and it's probably here to stay. So let's talk about what you should be doing about it. The first thing that you need to do is you need to maintain a dependencies list. You need to have a bill of materials. Your applications are mostly made up of open source components, and you need to have a way to keep track of what those components are. In order to be able to quickly respond to open source vulnerabilities when they are discovered, you need a way to quickly understand your company's exposure. So you need to maintain a dependencies list. The next thing we need to do is to have better due diligence on new dependencies. Now, I'm very surprised at the different processes organizations have when using open source versus commercial software. We have very different processes, or most organizations have very different processes between buying and free software. When you're looking at introducing open source software, this could be a typical process that is taken. So the first thing that you do is you have to search for the software and assess it. So this could be done in a few ways. It could be based on past experience. The developer could have used this before, had good experience with it. It could have been a long time ago and decide to use it. This could also be the first entry that you find from a Google search. So you decide to just look into that. Or it could be a response that you saw on Stack Overflow from someone who had a similar problem like what you're facing. And this assessment is usually done by a single developer, or this research is being done. The next step, once you determine the software, is you check if it works. Put it in there, run it, see if it works. If it does, you commit the code and you push it to the master repository, and that's the process. Usually in this case, the developers, usually one or maybe two or more, are the decision makers in this. Now, let's compare this process to the typical process that could be taken if you're about to spend $1 or more on the software. So the first thing you need to do is the software still needs to be assessed, but you might be doing a bit of comparison between a few alternatives, as you might need to put a business case for using that software. Security normally gets involved. You have to do a risk assessment. It wants to know things like what sort of data does it handle and does it store? Is there any PII data in there? Is there any business sensitive data in there? They would usually want to do a security review on it. Legal might also get involved. They might want to review the contract, the licenses, understand what the cost is, what's the level of support that we're going to get, and what kind of software maintenance are there. Now, I know I'm just simplifying everything, but what I'm trying to say is that there's more due diligence taken when we're about to spend $1 or more on software. Why is that so? Is it because there is more risk when we're using commercial software as compared to open source software? I don't believe so, but yet for most organizations, there is a large discrepancy in the way we review free software versus paid software. And I've heard that for some organizations, the open source selection process is like the Wild West, where anything goes. It shouldn't be. And we need to do better due diligence. Here are some questions we should be asking before we use open source software. First one is, do we really need this? Are we already using an open source software which does the same thing? Now, you don't want to have 5 different libraries doing the same thing. You want to be using one, and it has to be the highest quality. Is this software actively being developed? Now, an actively developed software is not an indicator that it would still be supported in the future. But a software that is no longer actively developed provides a pretty good indication that you should avoid using it. Is it popular? The idea behind this is that popular software are used a lot more and hence gets more scrutiny. As such, any vulnerabilities in the software would be quicker to be found than if it was not widely used. What license does it have? Now, it's not a security-specific question, but it is very important. And the last question, are there any known vulnerabilities? You do not want to pass any defects downstream. And now we're on to the last thing that you should do. You should update stale dependencies. A dependency is considered stale when there is a newer version available. Using the newest version would mean that you have the latest bug fixes and security fix. If you don't keep your dependencies up to date and you let them get really stale, when a security issue is discovered, it can be quite hard to upgrade, as there could be many breaking changes that you also need to address. There are a few ways you could do this. You could have a policy where teams should update all stale dependencies when making new changes. Or you could have a dedicated time set aside each month for updating stale dependencies, such as one developer for half a day every month doing technical dev work. I call it the open source tax. You get software for free so that you can build faster. You need to put the time back in to upgrade it. Or the last bit is you could automate it, as shown on the screen, using tools like Dependabot, which automatically upgrades stale dependencies and creates a pull request so that the changes for these updates can be merged in. So those are the three things. Let's look at an example implementation for how you could put that into your SDLC. So the first thing that you need to have is a local cache repository. This would be your bills of material. This is where you will know that all the open source that you're using is coming from. So the developers will retrieve the open source software from that repository when they're making the changes. They could obviously get it from anywhere else, but you would advocate that they'll be getting it from that local cache repository. When they've commit the changes, it goes into the code repository, which then triggers the build, and this would the build get kicked off on the build agent, which does its build, runs all its tests, and if everything passes, it goes into production or it goes into a release repository. You should be configuring your build agents to only allow dependencies to get pulled in from the local cache repository. So that way you can be sure that all your dependencies are actually from this local cache repository, and hence you'll have your bill of materials. The next thing is, how do you deal with new open source software? When there's a new open source software that wants to be, that teams like to add to the application, it needs to be reviewed. It could be done by a security champion or a team tech lead, and it goes through those questions that I just went through earlier. And if everything is good, it can be approved and it gets added to this local repository. So something really lightweight, but still good to have that quick review process. The other thing that you should be doing is in your build pipeline, you need to detect CVEs and report on them. And what I recommend is having time-based waivers, whereby once those CVEs are detected, you need to, report that to the team so they are made aware of it, and they need to be given time to address them. So what I've done is we have SLOs, service level objectives, and which states that you have to address certain vulnerabilities by a given time. Otherwise, the build would break. So the time that we had was based on the CVE's severity, and we have 2 weeks if it's a high, 3 months for a medium, and 6 months for a low. And the other thing that you also need to be doing is you need to be having regular code scanning for CVEs. So this will scan the code that is not actively developed. And you also need to make sure you update your stale dependencies. So in summary, your application is mostly written by strangers. And what you should be doing about it is you need to maintain a dependencies list. By doing that, allows you to know what open source components your organization is using, and you can quickly understand your company's exposure to any discovered open source vulnerabilities. You need to do better due diligence so that you use fewer open source suppliers and only the highest quality components. and you shouldn't allow stale dependencies. Never pass open source defects downstream. And with that, I end my talk. Thank you.